Hey everyone, welcome to episode 9 of the Kam Show. I'm your host, Kamran, and this week I'm going to be interviewing the lead scientist on Mars 2020, Dr. Ken Farley. Here we go. Dr. Ken Farley is a project scientist for the Mars 2020 Perseverance Rover and professor of geochemistry at the California Institute of Technology. He graduated summa cum laude at Yale University in chemistry and went on to get his PhD in earth sciences and chemistry from the Scripps Institute of Oceanography at the University of California, San Diego. In 2004, Dr. Farley became the chair of the Division of Geological and Planetary Sciences and became the project scientist for Mars 2020 rover in 2013. Currently, his work is centered on Martian geochronology and surface exposure dating using in situ noble gas-based techniques. Hello, Dr. Farley. How are you?
I'm doing just fine. And you?
I'm doing well. Thank you so much for taking the time to do this and answer my questions.
Yeah, you're welcome.
Yeah, so I guess let's start by getting to know you a little bit. What was your educational path from high school?
I actually took a fairly unusual pathway to get where I am. I got an undergraduate degree in chemistry, and while I was doing that, I got interested in geochemistry, and I went on to get a PhD in geochemistry. I did that for mostly studying terrestrial rocks, dating rocks, determining the ages of rocks in a laboratory that I built. And then about 10 years ago, I got pulled into planetary science.
Oh, wow, that's a lot of fun. So, what interested you in planetary science?
Well, I got invited to participate in the Curiosity mission, a rover mission with a very capable set of instruments, including an instrument that looked kind of similar to the instruments that I had in my ground-based laboratory.
Mm-hmm.
And I proposed that we could use those instruments on the rover to try to do something we do in my lab, which is date rocks, but to do it on Mars. And so
Okay.
we tried that. We were fairly successful in dating the Martian rocks, and I've been involved in Mars research ever since then.
Wow. So, moving on to Perseverance, what is Perseverance's main mission?
The highest level mission of Perseverance is to seek the signs of life. And one of the things I like to explain to people is we are not looking for things that are presently alive on the surface of Mars,
Mm-hmm.
because the surface of Mars is too cold and it's dry for any life as we know it, anywhere we can go. But it wasn't always that way. And the key observation that missions have made to Mars over the last decades is that long ago, more than about 3.5 billion years ago, the surface was very different. It was warmer and wetter, and there was flowing water on the surface. There would have been lakes and rivers, and we can see the geologic deposits from that time period today. And so we're going to go to look at those rocks to see if there is fossil evidence of life from that time period.
Oh, wow. So, what are you looking for this life? Like, what type of signatures would you expect to find?
We will be looking for with the rover is what we call biosignatures.
Mm-hmm.
And we are in a very fortunate situation in that the rocks that we will be looking at a place called Jezero Crater, which is on my backdrop here, they are rocks that were deposited in the bottom of a former lake. There used to be a lake there, and about 3.5 billion years ago. It turns out the oldest undisputed evidence of life on Earth is from a very similar kind of deposit in Western Australia.
Oh, wow.
And what we see using that as an analog is that that life was very primitive. It is essentially just microbial. And so we're looking at things that microbes leave behind. And one of the most prominent things that they leave behind is a texture in the rocks, which is produced when the microbes form a mat at the boundary between the water in the lake and the mud at the bottom of the lake. They form a film on the mud. And then that film gets buried and another film grows on it. It gets buried and another film grows on it. And so we're going to be looking for evidence of that type of layers of microbes.
Oh wow, so it's a lot like dinosaur fossils, where you can find the fossils in between layers of sediment.
Right, except for the difference is that at that time period in Earth's history, 3.5 billion years ago, life had not evolved to the complexity of things like dinosaurs or flowering plants. And so instead of looking for what we call macrofossils, large fossils, we're going to be looking for these microfossils.
I see. So, during the development of Perseverance, what were some challenges that arose?
Oh, boy, there were a lot of challenges, and this was new for me in that I started out, as I mentioned, as a scientist on the Curiosity mission, and I did not have to worry at all about all of the development that took to get Curiosity there. For Perseverance, I have been part of the team since its inception 8 years ago,
Hmm.
and I have lived through all the many challenges on the way. And I will tell you two of them. One of them is very close to the interest of science, and that is that another objective of this mission is to bring samples, to prepare samples that could be brought back to Earth in the future. So we call that caching, because what we're going to do is we're going to drill samples into very clean tubes, seal them, and leave them on the surface so that a future mission could pick them up and bring them back. But
Oh
the
wow.
real challenge for us in this is that another kind of biosignature, I described looking for these textures in rocks, but another kind of biosignature, which many people are familiar with, is organic matter. All the living things that we know of on Earth are made out of organic matter. And when that stuff, that organic matter, is deposited into the sediments, it stays behind. And in many cases, on Earth, is a very good indication of a biogenic origin of a feature that you're looking at. The challenge for us is that when we drill the samples on Mars, we cannot contaminate them with Earth sourced organic matter. And we had to build a system that was so clean that it would have no significant amount of terrestrial organic matter. And just as a comparison, the amount of organic matter that is present on Earth, when you look around, it is everywhere. So we had to build a system in the presence of all this organic matter to be super clean so that we could prepare stuff to be brought back to Earth ultra clean. So that was one challenge. Another very different kind of a challenge is in, I guess, about 4 years ago, we were doing parachute testing. Parachute testing was being done by NASA on a kind of a parachute very similar to ours.
Hmm.
That parachute failed twice. That would be very bad. That would be a very bad day trying to land on Mars if your parachute shredded.
Right.
And so we had to do a lot of additional parachute testing to prove that our parachute would work. And this involved sending a rocket high up in the Earth's atmosphere and getting the test parachute traveling at very high speeds to simulate what happens on Mars. Ultimately, we were successful in getting that parachute tested out. But I'll just point out that the Europeans were also planning to send a rover in 2020, and their parachute testing failed. They were not able to demonstrate that their parachute works. And this is one of the reasons why they ultimately had to skip this launch opportunity. They will have to wait another 2 years before they launch.
Oh wow. That kind of sucks after all the effort and work that goes into a
It sure
rover.
does.
So,
Absolutely.
so what about, so that's how the rover is certified, right? You have to not only to prove demonstrate the experiments, but also the launch and landing capabilities.
When we developed a rover, we go through a process of building it and testing it. So what you're calling certification, I would call the demonstration or the testing that what we have built actually works.
Oh,
And that is an enormous task. It's a much bigger task than you might initially think, because there are just thousands and thousands of things that actually have to work exactly like you think they do. And they have to do it under very challenging environmental conditions. So, as an example, surface of Mars is always cold. On the hottest day where we're going, it might get slightly above freezing,
Hmm.
but at night it goes to about minus 100 degrees centigrade.
Oh, wow.
It's really, really cold. And
Yeah.
then the next day it warms up again. And this cycling between very low temperatures and high temperatures is really hard on all sorts of things because they expand and contract, and electronics doesn't like to get cycled like that. And so we had to test a lot of our hardware in chambers where the temperature goes up and down repeatedly, hundreds or even thousands of times to simulate that. So there's been an enormous test campaign. And honestly, this is why, in general, these missions are successful because they have gone through a huge amount of testing before launch.
Awesome. And yeah, that's really important. That's why we hear so much about all the success of the Mars rovers.
Yeah, I'm hoping we're going to continue to hear that.
Yeah. So, what about some of the experiments on Perseverance?
Well, we have a suite of instruments that are primarily designed to be looking for biosignatures and for
Hmm.
determining what samples we should collect in preparation for them to be brought back to Earth. We also have another kind of uh, instruments that we have that instead of being primarily about looking at rocks and understanding the rocks, these are to demonstrate capabilities for the future. And two of them that get a lot of attention. First of all, we'll have a helicopter. We'll have a kind of a helicopter that's about this big with a very large pair of blades. So it'll be kind of like a drone, but with an enormous set of blades. And you need these huge blades because the atmospheric pressure is so thin on Mars that if you tried to fly with a typical terrestrial drone blade, you wouldn't get any lift at all. So we're going to
Oh,
test out
wow.
that technology. And this is, of course, the kind of thing that future human explorers, if they go to Mars, they could, instead of having to traverse great distances across hazardous terrain, they could just fly the drone, see what's out there. And similarly, we have a demonstration of the capability to a device that will convert atmospheric carbon dioxide into oxygen. So it uses electricity to turn CO2 into O2. And this is a very important capability for potential astronauts to go to Mars because if they could do that, if they could make oxygen that kind of live off the land, they don't have to bring the oxygen with them. And the amount of oxygen you would need, a little bit for breathing, but a lot of it for propellant to get back off of the surface. If you don't have to
Right.
bring all the oxygen with you, this task going to Mars gets much easier.
So, how did were you able to incorporate ingenuity into the rover? Was that always part of the design, or was it like added on as the technology matured?
Yeah, that's a great question. Ingenuity is the helicopter, and Ingenuity was added quite late. It was not part of the original manifest of what was going on the rover,
Hmm.
and it wasn't clear early on that the technology in its testing phase was going to work. The people that developed the helicopter were able to demonstrate in a vacuum chamber that it works, and the engineers building Perseverance created a small attachment point on the belly of the rover, the very bottom of the rover, between the wheels. So the helicopter is kind of nestled up between the wheels, and then it's got a shield on it so that when we land, it doesn't get smacked with rocks coming up off the ground.
I see. So, what will the Perseverance mission contribute to planetary science as a whole?
I think the major motivation that NASA has for many of its missions right now is looking for evidence of life beyond Earth. And our mission, 2020 Perseverance,
Hmm.
will contribute in one way that I think is important to kind of step back and think about. There's only one place besides Earth where we have evidence for all of the characteristics that life as we know it requires, and that's Mars. Previous rovers, especially Curiosity, have shown evidence in the rocks that there was a place that had all the characteristics that we believe are necessary for life. And at the same time on Earth, those same environments were inhabited. So we have picture two planets 3.5 billion years ago with lakes or shallow ocean water. On Earth, we know that life was there. It's recorded in the rocks. And now we're going to go to equivalent rocks on Mars, and we're going to see if life is there. That's the only place in the entire universe beside Earth where we know that those conditions pertain. And so it's important if life is there. It's important if life is not there. Because one of the really great questions at the discovery of all of these extrasolar planets that we've heard about over the last about 10 years is how common is it for life to originate? If you build it, will life come? If there's an environment that is inhabitable, will life just spontaneously appear? Or is it super special? Well, one way to try to address that question, go to a place that isn't Earth, that has all the characteristics that life as you know it might need, and see if life's there. And we will be able to say something about that.
Wow, that was really inspiring. So, how do you think the younger generation, like high school and undergrad students, how can they get involved in this field and type of research? And like, how could people interact with Perseverance while it's on Mars?
Well, I'll take those one at a time. Remind me if I forget the second one. The one thing I want to basically tell everybody is the idea right now is that Perseverance over the next about 5 years will collect samples and it will leave them on the surface of Mars for a future mission to pick up. That future mission is presently being discussed as a joint NASA ESA effort, and it is scheduled to launch as early as 2026.
Hmm.
And if that actually happens, which is it's still far enough away that there's a lot of technology that has to be invented, but if they manage to get it off in 2026, those samples will come back to Earth in 2031. And for a lot of young people out there, these samples are going to be a gold mine for understanding the planets, for understanding the history of the solar system, for understanding life. And so I think it's going to be revolutionary when those samples come back. It will be huge. And there's a really good analogy when the first samples came back from the moon. The field that I'm in, geochemistry,
Hmm.
it completely blossomed because all of a sudden there were fantastic samples to answer questions that you had never even thought of before. And we learned all sorts of stuff, and we're continuing to learn stuff from looking at the lunar rocks. The Martian samples, when they come back, will do that for understanding the way planets work, but also for this question about life. So there's a lot of opportunity. Young people, you're in the right place now to arrive. I'll be long retired when those samples come back, but they're coming, and I think there's a lot of opportunity there. In the shorter term, we on 2020 have a lot of uh, communication that we put out there. And we, for example, every day, all of our imagery goes straight up on the internet. So we will take pictures and they appear on the internet on our website, so you can see them as fast as we see them.
Awesome.
And so that's a really good opportunity to follow them with what we're doing. And we'll have lots of blogs and stuff like that. They haven't been set up yet. But, they will immediately, well, probably before we land, which is scheduled for February 8th of next year.
Awesome. All right, Dr. Farley, thank you so much for your time. I really appreciate it.
Been good talking to you.
Yeah, thank you so much for your time.
You're welcome.
All right,
Bye.
bye. All right, that is all that we had time for the interview. So if you had sent in some more questions, I'm gonna answer a couple of those right now. So the first question I'm gonna answer is how long is Perseverance scheduled and expected to last? Well, The rover's mission is scheduled to last 1.5 Mars years or 3 Earth years, but it's expected to last up to 14 years. The next question we're going to ask is, what is the nuclear battery that powers the rover and how will it work? Well, the rover is powered by a thermoelectric generator that charges the rover's 2 lithium-ion batteries. The natural decay of the radioisotope of plutonium is used to generate heat and convert that heat into electricity, which the rover can then use. This allows for flexibility in the timing of the rover due to the lack of reliance on sunlight, and should give the rover more consistent power. The next question is, how much horsepower or torque does the rover have? Perseverance will travel at a speed of 152 meters per hour, which is a little bit less than 0.1 miles per hour. However, the slow speed is made up by the 200 horsepower torque from the motors, as well as energy efficiency of fewer than 200 watts. That's truly amazing. Finally, does the rover use nitinol in the wheels? Nitinol is a nickel titanium alloy, but unfortunately, Perseverance uses aluminum wheels with titanium spikes for support and a little bit of like a spring cushion. Nitinol may be used in future rovers. Alright, everyone, that's it for this week and this episode. If you really enjoyed this interview and some of the stuff we talked about, make sure you leave a rating and follow us on Instagram. You can find the link down below. Also, yeah, if you can, give us a review and make sure you subscribe for new updates, as we'll have plenty more of these interviews in the future. Also, you can find some of the links of other stuff we talked about down below. Until the next time, Ad Astra.